Okay guys, this video is going to cover some of the beginning content for Unit 1 of the chemistry stuff. So this is the stuff that will be on the exam, the 40-minute exam you've got on chemistry. So to help you with preparing for the exam, in these videos what I've done is anytime something's in red, that's a definition that you will need to memorise for the exam. And I've also put down the left hand side the criteria, the things you need to be aiming to do. So by the end of this video you should hopefully be able to define and use relative atomic mass, determine the number of protons and electrons in an ion or an atom, calculate the relative formula mass of a compound, and calculate the relative atomic mass of an element from the relative masses and percentage abundances of isotopes. This shouldn't be too difficult. Hopefully this whole topic will just be a bit of a revision, but you want to make sure you've got it really firmly in your heads to help you do the rest of the course. Okay? So let's start with atomic number. This is always given the symbol Z, so if you want to write it as shorthand you can put Z, or sometimes you might see them ask for what's the Z number, and that just means the same thing, atomic number. The definition for that is just the number of protons in the nucleus of an atom. And when you see this written, like if you look it up on the periodic table, it's most often the number on the bottom. So if we look here, it's the number on the bottom, it's subscript. But if you're ever in any doubt, the atomic number is always the smallest number, because it's just the number of protons and nothing else. So in this example, we've got one proton in the nucleus of every hydrogen atom. If we look at He2, hopefully you're instantly going, there's going to be 2 protons. And if we're looking at Li3, that's 3 protons in the lithium atom. Okay, so that's atomic number. Pretty straightforward, hopefully happy with that. So our next one is mass number. So this is the other number that you will see when you look up elements on the periodic table. Atomic number was given Z, mass number is given the symbol A. And the definition for this one is it's the number of protons plus the number of neutrons in the nucleus of an atom. So again, that's the thing you just need to memorise so you can give it as a definition if asked. And the way you do this is the number of neutrons is just the atomic number, the mass number minus the atomic number. So the mass number is both of them together, the atomic number is just the protons. So if you want to find out how many neutrons, you do mass number minus proton number, or atomic number. So for hydrogen that's really easy, because if you look it's 1 and 1, so this is our atomic number, this is our mass number, so 1 proton, and then 1 minus 1 gives me no neutrons. If we look at helium, I've got an atomic number of 2 and a mass number of 4, so that means I have 2 protons. So to calculate my number of neutrons, I do 4 minus 2, which gives me 2 neutrons. Last one, lithium. If you want, pause it, give it a go yourself before you look at the answer. So for this one, my atomic number is 3, my mass number is 7, so I do 3 minus 7 to get my number of neutrons, and now I've got 3 protons, and therefore 4 neutrons. Okay? Again, pretty straightforward. Hopefully just a recap on something you already know from GCSE. Okay, next up is the number of electrons. So we've done protons, neutrons, electrons, the other fundamental thing inside our atoms. Now, for an atom, it's easy. In an atom, the number of electrons is always the same as the number of protons. Easy peasy. In an ion, you have a different number of electrons to protons. So to figure out how many electrons, you need to look at the charge. If there is a positive charge, that means there are more protons than electrons. So you need to, for the number of electrons, you would take away whatever the charge is to find the number of electrons. If it's a negative charge, that means there's more electrons there, so you need to add on whatever the charge is to get how many electrons. So let's look at some examples to see what I'm saying. So here I've got hydrogen, and it's got a positive charge. So if I look at the atomic number, it tells me there's 1 proton, but I have a positive charge, so that means that I have 1 more proton than electron. So I need to do 1 minus 1 to get my 0 electrons. If we look at chlorine minus, so I've got minus chlorine, and it's chlorine 35. So here I've got 17 protons. I know I've got a minus 1 charge, so that means I have 1 more electron than I do protons. So I'm going to do 17 plus 1 to get my 18 electrons. Last one, I've got oxygen with a 2- charge. So that's telling me that I have got 2 more electrons than protons. Since I've got 8 protons, I must have 10 electrons. Just got to be careful with this one. And as long as you remember that electrons are negative, it should help you remember if you're adding or subtracting. Okay, so next thing, this is the first thing on my list actually, relative atomic mass. We need to be able to define this. This is one of those ones you just got to memorize it. So the relative atomic mass of an element is the mean mass of the isotopes of an element compared to 1/12 of the mass of a carbon-12 atom. Just memorize it. It's just one of those things you just have to get stuck in your brain and regurgitate in the exam. The other thing you need to know is that because it's relative atomic mass, basically we're comparing the mass of atoms to carbon-12, it's relative, there is no unit. So for elements, the relative atomic mass is just their mass number. So it's pretty straightforward, pretty easy. So we should be able to use it quite easily already. Little note on isotopes. These are atoms with the same number of protons and electrons but different number of neutrons. So for instance here I've got 2 different isotopes of chlorine. I've got chlorine 35 and chlorine 37. They both have 17 protons because that's what makes them chlorine. They both have no charge, so they both have 17 electrons, but chlorine 35 has got 18 neutrons and chlorine 37 has got 20 neutrons. So they are the same element, but they are different isotopes. So that leads us to the idea of relative atomic masses for elements with multiple common isotopes, so where there's more than one isotope. So when there are more than one common isotopes of an element, what we do is we take into account how abundant each isotope is. So if there's more of one isotope than the other, then we sort of skew the mass that we're going to put on the periodic table in favour of the one that there's more of. And the way we do it is we just kind of take an average. So we do the atomic mass of isotope number 1 multiplied by its percentage of abundance, plus the atomic mass of isotope 2 multiplied by its percentage abundance, and then we divide by 100. Now if you had 3 isotopes, you just do the same thing, but for 3 of them instead of the 2 of them. So let's look at one with real numbers to help. So we've got chlorine 35, which is 75% abundant, and chlorine 37, which is 25% abundant. What I'd really love you to do is pause the video, have a go for yourself at doing the calculation. You should have space in your booklet. See what you come up with. I'm going to go through the answer here, but try it yourself first. See if you can do it. It'll give you that real boost of confidence when you find you got it right, okay? So hopefully what you've all written down is something that looks like this. 35 times 75, so the mass of the chlorine multiplied by its abundance, plus the mass of the other isotope multiplied by its abundance, so 37 times 25, divided by 100, which gives you 35.5. Now you might have already known that one, but they will ask you ones you won't know in the exam, and they will ask you to show your working. So you need to be able to write down the steps. The final thing you need to be able to do is to calculate the relative formula mass. So this is calculating the mass of compounds, not just elements. We've already done this, so this should be super easy because we did lots of this when we did our titrations. And all we do is the sum of the atomic masses of all the elements in the compound. So I've given you 3 there, H2O, H2SO4 and HCl. So why not do them yourself first and then check the answers, and then you can see if you're right. So for hydrogen, it's going to be, for water, it's going to be 18, because we've got 2 hydrogens and 1 oxygen, so that's 2 lots of 1 plus 16, which is 18. For H2SO4, it should come out at 98.1, so that's 2 lots of 1 plus 32.1 for the sulfur, plus 4 lots of 16 for the oxygen. And finally, for the HCl, it's 36.5, so it's 35.5 for the chlorine, plus 1 for the hydrogen. Okay, that is it for this session. You have now got a whole load of questions in your booklet to tackle and make sure that you really have this mastered. Hopefully, this is all as easy as I think it is. I have faith in you guys, so crack on and get those questions done.